Hey Pre-Calculus, I'm back with a new video. This is 1.4 part 4. It's all going to be about solving equations involving rational expressions. So here's our first one. A lot of people call these proportions when it's just one fraction is equal to another quantity. Your basic move is you want to get rid of it, and cross multiplication is an easy avenue to make that happen. So if you multiply 3x plus 1 times 4x minus 13, that expression should equal 6x minus 2 times 2x plus 5. The reason why that works is because if you found common denominators with these variable expressions, they would need to be multiplied by the identical denominator to make any sense at all. So I'd have to multiply this by 6x minus 2 and this by 6x minus 2 to find a common denominator. Similarly, I'd have to multiply this by 4x minus 13 and this by 4x minus 13 to find a common denominator. Once both fractions have identical denominators, you can set the tops equal to each other and solve. But that's pretty much what cross-multiplying accomplishes. So I just want you to know that that's where cross-multiplying comes from. That's why it works. It's not just some random technique that sounded good and then it ended up working. And at any rate, back to this, you need to expand the polynomial on the left and expand the one on the right by multiplication. So 3x times 4x is 12x squared, multiplied by negative 13. 4x, and then minus 13. There's the left-hand side. I think I'm just going to get rid of this because it's all up in my space. All right, on the other side, you get 12x squared, 3x, minus 4x, minus 10. Double check. You guys see everything? Good, good, good. Now, I think we should simplify both sides. This will be negative 35x. This will be positive 26x. Oh, the x squareds cancel. Which means just get x on one side and the constant on the other side, and that'll be your easiest route to solve for x. So I'm going to add 35x to both sides. And then add 10 to both sides. And what does that give us? That gives us negative 3 on the left and 61 on the right, 61x. Divide both sides by 61. And it's not the most elegant answer, but it'll do. Negative 3 over 61. Let's try another one. Looks a little bit different. So you've got two rational expressions added together, and it's equal to another one. Everybody's got a different denominator. However, by the way, it's number 9 in the textbook, page 53. However, 4x squared minus 9, the far most fraction. If you factor the denominator, you get 2x minus 3 times 2x plus 3. Nothing changed on top. So when you think about it, if every fraction gets a 2x minus 3 and a 2x plus 3, then we've got common denominators and stuff will start making sense. So this fraction, we need to multiply by 2x plus 3 on both the top and the bottom. So we've got 2x minus 3, 2x plus 3, and I'm going to go ahead and multiply this out. 8x plus 12. This fraction, we got to multiply by 2x minus 3 as well, and multiply the top by 2x minus 3. You know, since they've got common denominators, I can just make this one whole fraction on the left. All right, and then take 5 times 2x and get 10x. 5 times negative 3 is minus 15. That was a positive 8x. All right, how's that look? Great. So now, because they both have the same denominators, we don't need the denominators to compare. It's kind of like if somebody said, I have x over 7 and it equals 2 over 7. Well, you could just say, ditch the denominators and solve the tops. And that's what you can do when you have common denominators in an equation. Okay, so if the left fraction has a denominator that is identical to the right fraction's denominator, ditch them and then solve the top. So, you're gone. 10x plus 8x is 18x. Negative 15 plus 12 is minus 3. On the right-hand side, it's still just 14x plus 3. At which point, I'm going to just subtract 14x from both sides and add 3. 4x equals 6. Divide by 4, divide by 4. X is equal to 3 halves or 1 1/2. I'll just keep it at 3 halves. Let's look at number 13. Same page, same textbook. All right, I'm going to have to reference this. There's a lot going on here. Oh, there we go. There we go. Yeah. Oh, hold on. Hold the phone. Whoa. Going back to number 9. I was pretty darn confident with that answer, x equals 3 halves. But then it dawned on me. The original equation had variables in the denominator, which instantly created divide by 0 errors in certain spots. Here's what I mean by that. 2x plus 3 can't be 0. 2x minus 3 can't be 0. Guess what the solution is to that second equation? Add 3, divide by 2. 3 halves. 3 halves is an imposter equation. It's an extraneous solution. So, it actually does not work because it violates the domain issue. There is no solution to this equation. Wow. Good thing I caught that. So now we're ready to move on to number 13. Looks like the same situation's really happening. There's an x squared plus 3x. It has factors of x and x plus 3 if you actually factor it out. But I should also put this 4 over 1. There we go. So this guy needs an x. So multiply the bottom by x, multiply the top by x. This one needs an x plus 3. So multiply the top by x plus 3. Instead of multiplying the top by x plus 3, I'm just going to multiply by its expanded version, because I'm going to have to expand it anyway to combine with the x squared here and whatever happens with this stuff. So multiply the bottom by x times x plus 3. Blech. The top by x squared plus 3x. All right, so everybody on the left has got x times x plus 3. Everybody on the right has the same thing. So you therefore can ditch the denominator and just solve whatever the numerator is reading out to us. So here's x squared. Here's 1 times x. Here's 1 times 3. Here's negative 4 times x squared. Here's negative 4 times 3x. And then all that is set equal to 9. All right, so it looks like we got negative 3x on the left-hand side, x squared. So got it, got it. Negative 11x in the middle. And then it's 3 minus 9, negative 6 right there. At this point, hey, you know what? I'm going to divide everything by negative 1. On the left and on the right. The only reason why I'm doing that is because instead of working with all negative numbers, I think it would be much more convenient to work with all positive numbers. And I have that right to do so because it's an equation. You can divide the left and right side by any constant you want. So it's 3x squared plus 11x plus 6 is equal to 0. All right, I kind of ran out of room on the whiteboard. Is that enough space? Let's try it. Oh, this one's factorable because 18, 3 times 6, has a factor of 9 times 2, which is also, it adds up to 11. So here's what this would look like with AC method. You know what? No, I'm going to try the guess and check method. We know it's got to be 3x times x, and we need 3 times 3 is 9, and we need 2. 2 times x is 2. Both of them are positive because these are positive. So there's how you would employ a guess or check method right there. And then our final answer would be 3x plus 2 is equal to 0. And x plus 3 is equal to 0. Subtract the 2. Divide by 3. Now let's make sure that that's a legit solution. All right, it can't be negative 3, and it can't be 0. Negative 2/3 is okay. Oh, but they tried to get us. But we were paying attention this time. This is extraneous. So x equals negative 3 is an extraneous solution. Don't include that in the final answer. I mean, you can include that you're saying it's extraneous. Don't include negative 3 as one of your final answers. All right, I got 2 more examples for you, so let's just start a new video.